Hi everyone, this is Zaki in the channel Classes with Tyler, and today's topic is theory of numbers that we deal in mathematics. Now you know what is natural number? The natural numbers are the numbers like 1, 2, 3, etc. which are used in counting, and these are called to be the natural numbers, or we call it positive integers. Now what are the basic properties of the natural numbers? What are the basic properties of natural numbers? You know, in the system of natural numbers, we have two operations, you know, the addition, multiplication, division, subtraction, and some other operations are said to be the mathematical operations. So, we have two operations, addition and multiplication, with the following properties. Let A, B, C denote arbitrary natural numbers. Then, first, A plus B is a natural number. That is the sum of two natural numbers is a natural number. In terms of notations, we call it, if A, B, C belongs to the natural numbers or belongs to the set of natural numbers, this sign is, you know it, that belongs to. Then A plus B belongs to natural numbers. Like, you know, you can take any two natural numbers, say 5 and 3, that is 5 plus 3 is equal to 8, 8 is a natural number, like this thing, you know. Number 2, the commutative law of addition. A plus B is equal to B plus A. That is, if 3 plus 5, then you can say it is 5 plus 3. Associative law of addition. A plus B plus C. A, B, C are natural numbers. If you club up, if you add up this B plus C and you add it with A, then it is all but equal to A plus B plus C. A into B is a natural number. That is, the product of two natural numbers is a natural number. Okay. Commutative law of multiplication. It doesn't matter whether you multiply 3 into 5 or 5 into 3, the answer will be the same, and that is the natural number, that is 15. It's like that, A into B is equal to B into A. Next is associative law of multiplication. A into B into C. That equals to club up this A into B and multiply this into C, and that will be equal. Number 7 is existence of multiplicative identity. You know, we will be getting some multiplicative identity. Here it is 1. When you know A into 1 equals to A. And finally, number 8, this is the distributive law. A times B plus C, that equals to AB plus AC. These are the operations of the natural numbers, properties of it, with the operation addition and multiplication. Okay. Now, divisibility of integers. An integer A not equals to 0. 0 is an integer, you know, but we cannot take this A equals to 0. Now, an integer A not equals to 0 divides B, because you cannot divide something with 0. So, B, you are dividing B with A, where A not equals to 0. If there exists, here is a notation, you know, a symbol, okay, it is the mirror image of E. This is called there exists. There exists an integer M such that B is equal to M into A. Thus we write A divides B, a vertical line of division. A divides B, I have written it inside. A divides B, or you can say B is divisible by A. Now, if A doesn't divide B, then we write A, you know, the divisibility sign, and it is crossed. That is, A does not divide B, or you can say B is not divisible by A. Next is properties of divisibility. If, you know, A divides B and B divides C. Already you have learned. This is the sign like that thing. A divides B and B divides C implies A divides C. 2. A divides B and A divides C implies A divides MB plus minus NC for all. This sign stands for all Mn belongs to Z. Z is a set of integers. Okay, I'll be talking about separately on later. It has come from the German von Salem. Okay. Third, A divides B and B divides A implies A is equal to plus minus B. Number 4, A divides B where A is positive, B is positive implies A less than equals to B. Number 5, A divides B implies A divides BC for any integer C. And number 6, A divides B if. What does it if stands for? IFF, double F. This means if and only if. If and only if NA divides NB wherein this is not equals to 0. Now what are the tests of divisibility? A positive number, any such positive number, n is divisible by 2 if and only if. Last digit, that is the digit in the units place is even. Even means 0 is an even number, it can be 0 or any such number that which is divisible by 2. The number is divisible by 4 if and only if the number formed by the last 2 digits is divisible by 4. It is divisible by 8 if and only if the last 3 digits forms a number divisible by 8. The number is divisible by 3 if the sum of the digits is divisible by 3. It is divisible by 9 if the sum of the digits is divisible by 9. The number n is divisible by 5 if the last digit is either 0 or 5. The number is divisible by 25 if the number formed by the last 2 digits is divisible by 25. It is divisible by 125 if the number formed by the last 3 digits is divisible by 125. And finally, the number is divisible by 11 if the difference between the sum of the digits in the odd places, that starts from the right, you have to count from the right side the odd places, and the sum of the digits in the even places starting from the right is a multiple of 11. There are lots of examples and I have taken one for your explanation. That is 2580237 is the number. Now I want to check it whether this is divisible by 11. So what you have to do? You have to take the digits in the right place, right, counting from the right in the odd places. 7 plus 2, 9 plus 8, 17 plus 2, that is 19. And the even places, 3 plus 0, 3 plus 5, it is 8. 19 minus 8 is 11 and 11 is divisible by 11. So this entire number is divisible by 11. Now, it is Euclid's division lemma and algorithm. You know, the words that may not be known to you. First of all, let us know what is algorithm and lemma. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. This is called algorithm. And what is lemma? Lemma is a proven statement. It's a proven statement used for proving another statement. Lemma is a proven statement used for proving another statement. It is called to be lemma. Now Euclid's division lemma, it states that for any two positive integers a and b, we can find two unique unique whole numbers q and r such that a equals to bq plus r, where r is greater than equals to 0 or less than b. R must be always less than b. R can be 0 or it can be a positive number that is greater than equals to 0, but R must be less than b. Then a is the dividend, b is the divisor, q is the quotient, and r is said to be the remainder. So it can be written as dividend equals to divisor into quotient plus a remainder. So let us take some example, a small example, Say you are dividing 13 by 4. 13 is not divisible by 4. 12 is divisible by 4, but 13 is not divisible by 4. So if I am dividing this 13 with 4, then 13 is the dividend, 4 is the divisor. And 4 3s are 12, so 3 becomes the quotient and 1 becomes the remainder. That is, in that way you can say that 13 equals to 4 into 3 plus 1. This is said to be the Euclid's, okay? It is said to be the Euclid's division lemma. Okay, so in our next class, we will be using this division lemma of Euclid to find out the GCD, that is the greatest common divisor, or we call it HCF, highest common factor. Okay, we'll be using this lemma to find out that in our next class. Now friends, if you like this session, then I request you have a like or a subscription, subscribe. I request you to subscribe, to like or to share if you like this session of the video. Thank you.